Okay, so welcome to this lecture about Hoare logic. So before I start talking about Hoare logic, I would like to talk about the formalization projects. So this is about the point of the lecture or the course where you have the choice. We have to consider whether you want to do 2 homeworks or 1 project to get 20 points. You can even choose which 2 homeworks, so if it's 9 and 10 or 9, 11 or whichever combination are replaced by the project. And or even you can even do the project earlier if you're watching these videos earlier than you should. But typically you want to wait near the end of the course because this is where you're going to be the best, most skilled at using lean, and doing a project requires as much skill as possible, right? So if you want to do a project, I suggest that you get in touch with me and Gabrielle. So just drop us an email, tell us that yes, you want to do the project, maybe tell us which homeworks you want to replace with that, and also briefly describe your idea, just 1 paragraph explaining what you want to do. Because it is quite hard often for students or for beginners, novices in general, starting using a proof assistant to choose a project that's not too hard, not too easy, and that's interesting. So here are some ideas, but it's always good to discuss them with us. So from computer science, here's a whole list. So you could start with the while language and you could add more features to it, right? While is very minimalistic, has only 5 different types of statements. You could add more statements, different types of loops, and so on. You could verify some functional data structures. For example, balance trees, so you could show that insert operations preserve balancedness, or well, delete is usually too much for a project. We could at least have lookup and insert of some fairly easy functional data structure. Algorithms as well, small algorithms. And also the project, you don't have to finish it, right? So, I mean, let's put it this way. If you write 200 lines of lean code that compiles, and you have both definitions that make sense and some lemmas about those definitions, then you're going to get your 20 points, right? So the project is not there to punish you in any way. It's just an opportunity for you to, work on something nice. And I mean, don't worry about your grade. You'll get your points. It's just, I mean, if you submit only definitions and there's no actual proof, which I've seen before, then of course that's not that's not enough. This is a course about proving, not just about functional programming, right? So yeah, here are more suggestions. I'm not going to read all of them, but you based on your interests or what you've done in previous courses, or maybe you even have some of your own proofs that you would like to formalize. So that I mean, you're welcome. You could use Hoare logic, which we're going to describe today, and verify some programs using Hoare logic, some small programs. We're going to see some examples today, but the ones we do today are extremely small, so we could be a bit more ambitious there. There's also mathematics. So, I mean, graphs are not particularly pleasant to work with in a proof assistant, but because they're not, I mean, they're not an inductive type. They're not like lists. They're not, right? So you have to keep track of all the nodes and all the, what's it called? You have the edges, right? The edges between the nodes or vertices. Combinatorics, so that's also a favorite. And number theory. Or any other piece of mathematics that you want to formalize, really. But number theory has the advantage that we have a project here at the FU that's called Lean Forward, and it's about formalizing number theory, and it's well, what is it called? Algebraic number theory and related topics, and it's in collaboration with Sander Dame from the math department. Now, in case you have any doubts about the project, because I must say last year there was only 1 student who took the project, and that is way too little. And I heard lots of bad reasons for not doing the project, like, oh, I felt I would be penalized as opposed to, you know, doing the homework, which is easy. No, you'll get all your points if you do, you know, halfway decent projects, so don't worry. But in 2018, when we had the course, it was just pass fail, you know, well, you each, like the project didn't count there. It wasn't 20 points. It was either you do it or you don't. And then lots of people did it. Well, actually, I think it was even mandatory. Yeah, that's what it was. That's the best way to have students do their project, of course. And so, you know, we asked in the evaluation, how did you find the project? And this is like the copy pasted, right? So I didn't cheat here. Enjoyable, fun, and hard. You know, that's great. This is how you know, this is how science should be: fun and hard. Hmm. Yeah, you see the format was excellent, really liked it, great way of learning. I wish I could do more of that, you see. It's like, it sounds as if they're talking about a very different activity than a formalization project. I'm not sure what you think, but it's great, lots of fun actually. Why actually? Of course it's a lot of fun, there's no actually there. 3 exclamation mark, very helpful, and so on. And yeah, I think nobody. Well, okay, right. I think I did filter out some answers as well, because back then it was mandatory, so some students were anxious, oh, which project should I do, and so on. And now we remove this anxiety, but by giving you the choice. But if you do it, then you have all these benefits, all this joy and positivity, and so on. And that's it. Next segment will be about hard triples.